It began with a whisper in the darkness. On October 3, 2025, the interstellar comet 3I Atlas made its closest approach to Mars. The planet's orbiters, NASA's Mars Reconnaissance Orbiter, MRO, ESA's Mars Express, and the ExoMars Trace Gas Orbiter, TGO, pointed their instruments at the visitor from outside our solar system. It was their moment to reveal secrets. Instead, silence. More than a week has passed since the flyby. No press release. No image gallery. No data dump. The world waits. And so do we. Why this radio blackout? Because what the instruments may have captured is too extraordinary, too unsettling to share without preparation. Tonight, we step into that silence. We follow the comet's path, confront its paradoxes, and uncover anomalies that defy not only expectation, but potentially the laws we thought we understood. This is not just a comet. This is a messenger from the void. The comet's trajectory was precise and bold. It arrived at Mars on October 3rd, making it one of the closest planetary flybys an interstellar object has ever made. Observatories aboard Mars were primed to scan it. High-resolution cameras like HiRISE were expected to deliver images with 30 km pixel clarity, unprecedented for such a distant, fleeting target. Spectrometers, ultraviolet imagers, and color cameras stood ready to analyze the gas and dust plumes. The anticipation was electric. But days turned to silence. No public data from MRO or TGO or Mars Express have emerged. Some privately processed images, stacks from Perseverance's Mastcam-Z, carved out a faint smudge where 3I Atlas was expected, but nothing conclusive was released by official agencies. Astronomer Avi Loeb has speculated that the silence is tactical, either because the data are being massaged or sanitized, or because they contain a discovery too jarring for immediate release. Silence becomes a canvas for suspicion. Was it a data backlog? A spacecraft scheduling conflict? The US government shutdown? Loeb himself concedes delays may be real, but insists those mundane explanations cannot alone justify a blackout of this magnitude. The world is watching, waiting, and whispering. Already before the Mars flyby, scientists had collected thousands of observations from Earth and space telescopes. More than 4,000 astrometric measurements from 227 observatories spanning May 15 to September 23, 2025, were used to model 3I Atlas's motion. The result: the comet adhered almost perfectly to a pure gravitational path, with negligible non-gravitational acceleration. That discovery became an impossible paradox. You see, 3I Atlas is shedding gas, 150 kilograms of molecules every second, as sunlight warms its surface and ices sublimate. That outgassing acts like microscopic thrusters, and yet the comet refuses to deviate. To resist such thrust, the nucleus must be stupendously massive. The friction of jet forces should nudge it, yet it holds its line. From those models, the team deduced a minimum mass of 33 billion tons. If the nucleus were much smaller, even modest jetting would alter its orbit detectably. To explain this resilience, either the comet is far larger and denser than we assume, or its outgassing is balanced with extreme precision. This is anomaly number 1, the mass anomaly. To accept it as natural, one must accept extreme improbability, that before discovering this leviathan, astronomers failed to observe hundreds of thousands of smaller interstellar bodies. Why would a 5-kilometer or larger interstellar object show up before the myriad of 0.1 to 1 kilometer bodies we expect to dominate? It implies a statistical miracle, or intent. Next, anomaly number 2, industrial nickel. Spectroscopic studies, especially from the Very Large Telescope, VLT, discovered unexpectedly high concentrations of nickel vapor in the comet's coma, even when iron vapor was undetected. In solar system comets, metals like nickel and iron often vaporize together under heat stress. But here, nickel vapor appears while iron remains silent. How can nickel volatilize in such cold environments? Some researchers propose organometallic compounds, nickel carbonyl or nickel bound to complex organic molecules, that decompose and release nickel at low energy. The mismatch of nickel and iron is highly unusual and raises red flags. Industrial alloys often show high nickel relative to iron. Could we be seeing the chemistry of engineered materials? Avi Loeb has urged the possibility that this nickel signature may hint at manufactured structure, not merely random cosmic dust. Yet many in the community warn caution. Complexity of comet chemistry is vast, and organic metal compounds are not unknown. Now arrives anomaly number 3, strange light. Polarimetric observations across several telescopes, including VLT, NOT, and Rosen Observatory, showed a deep negative polarization branch in the reflected sunlight. The minimum polarization reached about -2.7% at a phase angle near 7 degrees, and the inversion angle, where polarization flips sign, is 17 degrees, a combination never before seen in any comet or asteroid. Negative polarization means that the electric vector of scattered light lies preferentially in the plane containing sun, object, observer, rather than perpendicular, a subtle optical effect sensitive to dust grain size, porosity, structure, and composition. The curve for 3I Atlas is unlike any known solar system body. It more closely resembles some trans-Neptunian objects or centaurs. This implies the comet's dust is extremely porous or irregular, perhaps featuring fractal structures or nanophase materials assembled in exotic conditions. The light speaks of a material architecture very different from typical comet dust. Also worth noting, some telescopic images suggest an anti-tail, a dust extension pointing toward the sun, rather than away, a rare phenomenon. That anti-tail was modeled as an anisotropic extension of sublimating ice grains surviving longer on the sunward side. And then we reach anomaly number 4, the perfect trajectory. The path of 3I Atlas is aligned within 5 degrees of the ecliptic plane, the flat disk in which most planets orbit, a chance occurrence of about 0.2%. Even more, its timing and approach vector nearly skim close passes to Mars, Venus, and Jupiter, unlikely coincidences unless guided. Avi Loeb and others have pointed out that such fine-tuning of trajectory hints at deliberate design, not random drift from the galaxy. Even more provocative, its inbound direction lies close, within 9 degrees, of the direction of the 1977 "Wow!" radio signal. While that might be coincidence, it's one more knot in the tapestry of anomalies. The stage was set massive, nickel-rich, light-strange, and perfectly aligned. The Mars flyby held the promise of decisive images and spectra, but NASA and ESA fell silent. The world demanded answers. What are they hiding? Perhaps a perfect cylinder, caught by Perseverance's cameras, as some rumors suggest. Perhaps data so anomalous that releasing it rashly would provoke chaos in scientific circles. Or perhaps the agencies are still grappling with calibration, data corruption, or internal leaks. Still, the flow of data will not stop forever. After all, 3I Atlas is heading toward perihelion on October 29, 2025, from the Sun. After that, it will loop outward, passing Jupiter in March 2026. Observers expect new measurements from JWST, Hubble, ground telescopes, and eventually Mars, Jupiter, and solar pointers. It began with a whisper in the darkness. On October 3, 2025, the interstellar comet 3I Atlas made its closest approach to Mars. The planet's orbiters, NASA's Mars Reconnaissance Orbiter, MRO, ESA's Mars Express, and the ExoMars Trace Gas Orbiter, TGO, pointed their instruments at the visitor from outside our solar system. It was their moment to reveal secrets. Instead, silence. More than a week has passed since the flyby. No press release. No image gallery. No data dump. The world waits. And so do we. Why this radio blackout? Because what the instruments may have captured is too extraordinary, too unsettling to share without preparation. Tonight, we step into that silence. We follow the comet's path, confront its paradoxes, and uncover anomalies that defy not only expectation, but potentially the laws we thought we understood. This is not just a comet. This is a messenger from the void. The comet's trajectory was precise and bold. It arrived at Mars, 29 million kilometers, on October 3rd, making it one of the closest planetary flybys an interstellar object has ever made. Observatories aboard Mars were primed to scan it. High-resolution cameras like HiRISE were expected to deliver images with 30 kilometers pixel clarity, unprecedented for such a distant, fleeting target. Spectrometers, ultraviolet imagers, and color cameras stood ready to analyze the gas and dust plumes. The anticipation was electric. But days turned to silence. No public data from MRO or TGO or Mars Express have emerged. Some privately processed images, stacks from Perseverance's Mastcam-Z, carved out a faint smudge where 3I Atlas was expected, but nothing conclusive was released by official agencies. Astronomer Avi Loeb has speculated that the silence is tactical, either because the data are being massaged or sanitized, or because they contain a discovery too jarring for immediate release. Silence becomes a canvas for suspicion. Was it a data backlog? A spacecraft scheduling conflict? The US government shutdown? Loeb himself concedes delays may be real, but insists those mundane explanations cannot alone justify a blackout of this magnitude. The world is watching, waiting, and whispering. Already before the Mars flyby, scientists had collected thousands of observations from Earth and space telescopes. More than 4,000 astrometric measurements from 227 observatories spanning May 15 to September 23, 2025, were used to model 3I Atlas's motion. The result: the comet adhered almost perfectly to a pure gravitational path, with negligible non-gravitational acceleration. That discovery became an impossible paradox. You see, 3I Atlas is shedding gas, 150 kilograms of molecules every second, as sunlight warms its surface and ices sublimate. That outgassing acts like microscopic thrusters, and yet the comet refuses to deviate. To resist such thrust, the nucleus must be stupendously massive. The friction of jet forces should nudge it, yet it holds its line. From those models, the team deduced a minimum mass of 33 billion tons. If the nucleus were much smaller, even modest jetting would alter its orbit detectably. To explain this resilience, either the comet is far larger and denser than we assume, or its outgassing is balanced with extreme precision. This is anomaly number 1, the mass anomaly. To accept it as natural, one must accept extreme improbability, that before discovering this leviathan, astronomers failed to observe hundreds of thousands of smaller interstellar bodies. Why would a 5-kilometer or larger interstellar object show up before the myriad of 0.1 to 1 kilometer bodies we expect to dominate? It implies a statistical miracle, or intent. Next, anomaly number 2, industrial nickel. Spectroscopic studies, especially from the Very Large Telescope, VLT, discovered unexpectedly high concentrations of nickel vapor in the comet's coma, even when iron vapor was undetected. In solar system comets, metals like nickel and iron often vaporize together under heat stress. But here, nickel vapor appears while iron remains silent. How can nickel volatilize in such cold environments? Some researchers propose organometallic compounds, nickel carbonyl or nickel bound to complex organic molecules, that decompose and release nickel at low energy. The mismatch of nickel and iron is highly unusual and raises red flags. Industrial alloys often show high nickel relative to iron. Could we be seeing the chemistry of engineered materials? Avi Loeb has urged the possibility that this nickel signature may hint at manufactured structure, not merely random cosmic dust. Yet many in the community warn caution. Complexity of comet chemistry is vast, and organic metal compounds are not unknown. Now arrives anomaly number 3, strange light. Polarimetric observations across several telescopes, including VLT, NOT, and Rosen Observatory, showed a deep negative polarization branch in the reflected sunlight. The minimum polarization reached about -2.7% at a phase angle near 7 degrees, and the inversion angle, where polarization flips sign, is 17 degrees, a combination never before seen in any comet or asteroid. Negative polarization means that the electric vector of scattered light lies preferentially in the plane containing sun, object, observer, rather than perpendicular, a subtle optical effect sensitive to dust grain size, porosity, structure, and composition. The curve for 3I Atlas is unlike any known solar system body. It more closely resembles some trans-Neptunian objects or centaurs. This implies the comet's dust is extremely porous or irregular, perhaps featuring fractal structures or nanophase materials assembled in exotic conditions. The light speaks of a material architecture very different from typical comet dust. Also worth noting, some telescopic images suggest an antitail, a dust extension pointing toward the sun, rather than away, a rare phenomenon. That antitail was modeled as an anisotropic extension of sublimating ice grains surviving longer on the sunward side. AR-14. And then we reach anomaly number 4, the perfect trajectory. The path of 3I Atlas is aligned within 5 degrees of the ecliptic plane, the flat disk in which most planets orbit, a chance occurrence of about 0.2%. Even more, its timing and approach vector nearly skim close passes to Mars, Venus, and Jupiter, unlikely coincidences unless guided. Avi Loeb and others have pointed out that such fine-tuning of trajectory hints at deliberate design, not random drift from the galaxy. Even more provocative, its inbound direction lies close, within 9 degrees, of the direction of the 1977 WOW! Radio signal. While that might be coincidence, it's one more knot in the tapestry of anomalies. The stage was set massive, nickel-rich, light-strange, and perfectly aligned. The Mars flyby held the promise of decisive images and spectra, but NASA and ESA fell silent. The world demanded answers. What are they hiding? Perhaps a perfect cylinder, caught by Perseverance's cameras, as some rumors suggest. Perhaps data so anomalous that releasing it rashly would provoke chaos in scientific circles. Or perhaps the agencies are still grappling with calibration, data corruption, or internal leaks. Still, the flow of data will not stop forever. After all, 3I Atlas is heading toward perihelion on October 29, 2025, from the Sun. After that, it will loop outward, passing Jupiter in March 2026. Observers expect new measurements from JWST, Hubble, ground telescopes, and eventually Mars, Jupiter, and solar pointers. The numbers alone are enough to shatter expectations. 33 billion tons. That is the lower mass bound for 3I Atlas, derived from the fact that despite hurling out nearly 150 kilograms of gas every second, the object stays perfectly on course. Compare that with 1I Oumuamua, whose estimated mass was perhaps a few tens of thousands of tons at most. By weight, Atlas dwarfs it by a factor of 1,000,000. This creates a brutal contradiction. If interstellar objects follow a normal size distribution, with many small fragments and only a few giants, then statistically astronomers should have found hundreds of tiny interstellar rocks before discovering one this large. And yet, in less than a decade, humanity has logged 3 such visitors: Oumuamua, Borisov, and now Atlas. Of those, Atlas is incomparably massive. Either we stumbled upon an absurd miracle of chance, or something about its origin violates what we thought we knew. This is where suspicion takes root. Scientists try to stay grounded, but when faced with the mass anomaly, even cautious voices admit the possibility of deliberate design. Avi Loeb, known for his work on Oumuamua, warns that such a colossal object could be a kind of Trojan horse. A test, a probe, or perhaps even debris from a structure designed far away. He doesn't claim certainty, only that the data allow questions we must not ignore. But weight is only one of the anomalies. The chemistry of Atlas is stranger still. Spectroscopy from the Very Large Telescope in Chile revealed a coma rich in nickel vapor, far richer than any comet from our solar system. In fact, the nickel appeared where iron did not. Under normal conditions, nickel and iron behave as partners. They vaporize together, locked in the mineral cages of silicates and sulfides. For one to appear without the other is like finding smoke without fire. The simplest explanation: nickel atoms are being released not from deep mineral lattices, but from fragile organometallic compounds. In laboratory chemistry on Earth, we know one such species well, nickel carbonyl. It forms under specific conditions of pressure and carbon monoxide exposure, and it breaks apart easily, releasing nickel vapor. Why would such compounds exist in a natural comet? Some theorists suggest they form in the cold void of interstellar clouds, where exotic chemistry takes hold. Others whisper of something more deliberate. Industrial processes create nickel-rich alloys. Nickel is prized in engineering for its strength, corrosion resistance, and magnetic properties. A comet that carries excess nickel vapor, divorced from iron, begins to look less like an icy rock and more like an artifact. And then came the third anomaly, its light. The sunlight scattered from Atlas carried a fingerprint unlike anything in astronomy's archives. Polarization curves, which describe how dust grains twist and filter light, revealed extreme negative polarization, deeper than typical comets, shifted at strange phase angles. To the untrained eye, that may sound abstract. But to astronomers, it screamed of alien dust. Dust grains in comets are usually fluffy, porous, and irregular. They produce a polarization curve with familiar shape and inversion point. Atlas's dust broke the pattern. It was as if its grains had been assembled under different physics, fractal structures, nanomaterials, or glassy cages with voids. One team noted its curve matched nothing in known comets, but resembled some trans-Neptunian objects and centaurs. The implication? Atlas was born under conditions never before witnessed, forged under another star, carrying a memory of alien chemistry. And yet, among all these mysteries, nothing chills the spine quite like the fourth anomaly, the trajectory. 3I Atlas follows a hyperbolic path, yes, but one that lies almost perfectly in the plane of the solar system. A mere 5 degrees separate its path from the ecliptic. Statistically, the chance of this alignment is around 0.2%. In other words, astronomers would need to discover hundreds of random interstellar visitors before one happened to align so cleanly. And yet, here it is, after only 2 previous detections. It is not only aligned, it is purposeful. It swung past Mars, then will skim close to Jupiter's realm. Some have speculated such a trajectory could be designed, a probe using planetary flybys to map or measure orbital planes, or to decelerate into the solar system itself. To believers, this is the perfect trajectory, a path that looks more navigated than accidental. Now layer upon this the silence. NASA's orbiters were watching. ESA's orbiter was watching. These spacecraft are bristling with cameras and spectrometers. They could have returned stunning images, sharper than anything Earth-based telescopes could dream of. And yet, after October 3rd, nothing. Days turned to a week into 2. Still nothing. Official explanations pointed to delays, calibration, bandwidth, even the US government shutdown. But suspicion doesn't wait politely for bureaucracy. Rumors erupted. Some insiders whisper that Perseverance on Mars might have imaged a geometric silhouette, a perfect cylinder, glinting against the black. Others claim TGO detected emissions inconsistent with cometary physics. Avi Loeb has offered cautious explanations. Yes, there are real delays in data processing, but he too cannot deny the timing looks suspicious. To the public, it feels like a blackout. And silence, as always, is the best fuel for conspiracy. Even if we assume innocent delays, the fact remains, Atlas has forced astronomers to confront a wall of impossibilities. It is massive beyond statistical expectation. It resists acceleration while bleeding gas. Its dust carries the signature of exotic chemistry. Its metals defy temperature logic. And its trajectory is almost too perfect. Each anomaly could perhaps be explained away on its own. But together, they weave a story that looks less like accident and more like intent. Meanwhile, the comet continues its journey. On October 29th, it will swing through perihelion from the Sun. That is when its activity should peak, jets flaring, dust clouds swelling. By early December, it will be visible again from Earth's night skies, faint but real, offering astronomers one more chance to test their theories. Then in March 2026, it will pass within of Jupiter, a giant meeting a giant. Europe's JUICE spacecraft will turn its instruments toward the Traveler, one of its earliest unexpected science campaigns. If the Mars blackout persists until then, suspicion will deepen. If agencies delay the data again, questions will sharpen. Already, speculation ranges from alien probes to ancient interstellar wreckage to cosmic coincidences of staggering unlikelihood. Whatever the truth, the silence only amplifies the mystery. And so, we are left with a question that lingers like a shadow. Is 3I Atlas simply the strangest comet in cosmic history? Or is it something else entirely? A message in matter, a 33 billion-ton Trojan horse drifting silently into our neighborhood. The silence stretched on as October deepened. Every day without a word from NASA or ESA tightened the knot of unease. The comet had brushed past Mars. Its bluish coma, recorded by Hubble weeks earlier, was expected to bloom as sunlight dug deeper into its ices. Perihelion was approaching. And still, no release, no images, no confirmation. For scientists, this was agony. A close planetary flyby is priceless. Data from Mars orbiters could have settled key debates at once. How large is the nucleus? Are the jets symmetric? What is the real dust-to-gas ratio? Instead, researchers were left piecing together faint smears from ground-based observatories. Yet even those smears contained shocks. Polarimetric studies revealed more evidence of exotic dust. The negative polarization, already noted before, now appeared stronger at certain phase angles. It was as if the comet's grains were hollow shells or fractal networks, scattering light in ways never documented in solar system comets. A few astronomers compared it to aerogel, the synthetic, porous material humans use as insulation in spacecraft. That comparison set imaginations ablaze. If the dust of Atlas resembles our engineered materials, is that coincidence, or clue? Meanwhile, spectroscopic campaigns pressed on. JWST pointed its gaze in August, measuring gas ratios. The result was startling, a CO2 to H2O ratio of 7.6. Most comets in our system are water-rich, with carbon dioxide a minor constituent. Atlas was inverted, CO2 dominated. This explained its early activity, where water should have been frozen solid. But it raised new questions. Did Atlas form in the outermost zones of its home system, where CO2 ice was stable? Or had it undergone intense radiation, baking away its water long ago? Both options implied a very different birth environment than the comets we know. And then came the nickel puzzle again. VLT detected nickel vapor far from the Sun, where sublimation temperatures made no sense. Iron, its usual companion, stayed hidden until the comet neared. The decoupling was unmistakable. To explain it naturally, some invoked fragile complexes. Nickel bonded to carbon monoxide or embedded in organic molecules. These could break down easily, releasing nickel at cold temperatures. but to many, the smell of metallurgy lingered. Nickel without iron is not just a chemical oddity, it is the recipe for stainless steel. At conferences, debates grew sharp. Mainstream voices urged restraint. Extraordinary claims require extraordinary evidence. Others insisted the anomalies demanded open-mindedness. And Avi Loeb, unafraid of controversy, sharpened his warnings. He spoke of a Trojan horse, a massive object, hiding behind the innocent guise of a comet, slipping quietly into our solar system. If its mass and trajectory are real, then, in Loeb's words, we must consider the technological possibility. Loeb pointed out another eerie coincidence. The inbound direction of Atlas was only a few degrees from the famed "wow" signal of 1977, the strongest unexplained radio burst ever detected. Coincidence, perhaps. But when layered atop mass, nickel, light, and trajectory anomalies, the effect was undeniable. The story was no longer just science, it was myth in the making. Perihelion loomed. On October 29th, Atlas would pass just from the Sun, close enough for its nucleus to endure maximum stress. Some scientists quietly speculated it might fragment, as many comets do when heated. If that happened, we would learn more in an instant than in months of speculation. A breakup could expose the nucleus, reveal its density, its structure, maybe even its secrets. But others feared the opposite. If Atlas held together under perihelion heat, it would only deepen the mystery of its strength. Still, the official channels stayed quiet. The Mars flyby data was in the vault, inaccessible. Amateur astronomers strained for glimpses, but the comet's faintness and distance kept it frustratingly subtle. Predictions suggested it would not brighten beyond magnitude 11.5, just outside the reach of most backyard telescopes. It was as though Atlas itself resisted scrutiny, cloaked in distance, teasing humanity with just enough to drive us mad. As speculation filled the void, a darker narrative began to spread online. Was NASA deliberately withholding evidence of artificial structure? Were the orbiters ordered to black out? Some conspiracy forums circulated blurry images purporting to show a cylinder or a geometric shadow, allegedly from Perseverance. Mainstream scientists dismissed these as pareidolia, tricks of noise and expectation. But absence of official rebuttal only fanned the flames. Beyond the noise, the comet pressed onward. After perihelion, it would climb north of the ecliptic, heading toward a rendezvous with Jupiter in March 2026. The JUICE spacecraft was scheduled to capture data during the flyby, another rare chance to study it with instruments already in place. Whether JUICE's results would ever be released without delay became the new question. If Atlas truly weighs billions of tons, its significance is immense. Such a mass implies a planetesimal, a primordial chunk of planetary birth, ejected from another system millions or billions of years ago. If that is the case, then we are witnessing not just a comet, but a fossil, an alien world's building block drifting into our neighborhood. But if Atlas is more than natural, if its anomalies point to construction, to organization, then the implications are staggering. A 33 billion-ton object could be anything from an ancient derelict to a disguised probe. In either case, it is no longer simply science, it is contact of a kind. And so, in this vacuum of silence, two worlds exist. In one, Atlas is a comet unlike any other, a marvel of physics and chemistry forged by nature under alien stars. In the other, it is a Trojan horse, massive, metallic, aligned, intentional. Both worlds demand evidence. Both worlds wait for the veil to lift. The night of perihelion will decide much. If the comet brightens, fragments, or flares, telescopes will capture it. If it stays silent, hard and unyielding, the mystery will thicken. Either way, Atlas will write itself into the history books as the strangest wanderer we have ever known. October 29, 2025. The day of perihelion. The day when 3I Atlas came closest to the Sun, between Earth and Mars, closer than it had been since entering our system. For comets, this is the trial by fire. Heat soaks into the nucleus, volatile ices boil, jets intensify, stresses fracture the body. Many comets don't survive their perihelion passage. Some crumble into pieces, their skeletal dust tails the only record of their former glory. But Atlas? It defied the script. Reports from ground-based observatories suggested activity increased as expected. The bluish coma expanded, tails lengthened. Yet no catastrophic breakup was observed. Atlas held together. The nucleus, whether 5 kilometers across or larger, bore the heat. To many, this resilience was shocking. A fragile comet should have cracked under such conditions. A 33 billion-ton body of stone and ice, perhaps even metal-rich, did not. Once again, Atlas appeared not like a comet, but like a fortress. Silence still loomed from NASA and ESA. No data from the Mars flyby. No confirmation from the orbiters. The blackout continued. Even as amateur astronomers pointed out faint signs of new jets, official channels stayed tight-lipped. It was as if the agencies were waiting for something, or suppressing something. Scientists debated openly. If Atlas truly has a nucleus that dense, it could be unlike any comet ever seen. Some wondered if it might be a planetesimal remnant, a fragment from the dawn of another star system, ejected during planet formation. These primordial chunks, hardened by time, could indeed survive heat that destroys smaller, fluffier comets. But others pointed back to the anomalies, the nickel-to-iron ratio, the perfect trajectory, the absence of measurable acceleration despite constant outgassing. "We're not dealing with a typical planetesimal," one researcher commented. "We're dealing with something we can't yet categorize." As perihelion passed, the comet began its outbound leg. For Earth observers, this was both good and bad news. The geometry of its orbit meant that by December, it would reappear in the night sky, faint but detectable with medium telescopes. Amateur groups prepared to track it, hoping to pierce the veil left by silent agencies. But the true prize was months away, Jupiter. On March 16, 2026, Atlas will pass just from Jupiter, less than 54 million kilometers. That is close enough for JUICE, the European Space Agency's new flagship mission to the Jovian system, to aim its instruments directly at the comet. JUICE was never designed to chase interstellar objects, but fate put Atlas on its doorstep. Cameras, spectrometers, particle detectors, all could be turned toward this alien visitor. For scientists hungry for data, it was an unexpected miracle. Yet here, too, questions of silence rise. If the Mars flyby produced nothing, will ESA share JUICE's results? Or will we face another blackout, another gap filled by rumor and speculation? By then, the comet will be outbound, drifting into the black, never to return. Our last chance to decode its secrets will slip away with it. Meanwhile, theorists are sharpening models. One school argues Atlas is simply an extreme statistical outlier, a giant interstellar rock found early by sheer luck. Another proposes our understanding of interstellar size distributions is flawed. Perhaps giant planetesimals are far more common than we thought, and we've only just begun to glimpse them. But those explanations strain probability. If nature regularly ejects 33 billion-ton objects, then our galaxy must be littered with them, and Earth should have seen far more collisions in its history. The geological record does not support that. Others take a different approach. They imagine symmetry, outgassing perfectly balanced around the comet's body, canceling any rocket effect. But that level of symmetry over months, as different phases rotate into sunlight, borders on impossible. A random, tumbling object should show jitter, irregularity, tiny deviations. Atlas does not. Its orbit is smooth, precise, unyielding. Which leaves the final possibility, intent. That the mass, the nickel, the light, the trajectory, taken together, are not accidents, but features. If Atlas is natural, it is the strangest natural object ever discovered. If it is artificial, it may be the most significant encounter in human history. Speculation runs wild. Some envision an ancient derelict, wandering the galaxy for eons, disguised as a comet. Others imagine a probe, designed to mimic comets to hide in plain sight, moving along trajectories that allow it to map planetary orbits. A Trojan horse, in Loeb's words, harmless until it isn't. The most radical ideas suggest the nucleus itself might be hollow, metallic, a shell or engine wrapped in layers of dust and ice. Nothing in the data rules this out, yet nothing proves it either. As the comet arcs outward, the stakes grow. The Jupiter encounter in 2026 could decide the debate. If JUICE measures a mass consistent with 33 billion tons, if it confirms the nickel chemistry, if it captures detailed images of the nucleus, then the case will sharpen. Either for an extraordinary natural object, or for something far beyond. And so the silence of the agencies becomes louder than any press release. In an age where data flows instantly, where citizen scientists track asteroids and comets nightly, why should an interstellar visitor remain hidden? Why delay? Why withhold? The lack of answers has become its own anomaly, the fifth, unofficial anomaly of 3I Atlas. By December, when Atlas returns to Earth's skies, telescopes across the world will try again. By March, JUICE will give us another chance. And beyond that, the comet will fade forever, out into the dark between stars. We may never see another of its kind. Or perhaps, as some believe, we will see more, and soon. But for now, the story is unfinished. Atlas has survived the sun's heat. It carries its secrets onward. And all we can do is watch, speculate, and wait for the silence to break. March 16th, 2026. Mark this date, because it could be the day humanity receives its clearest evidence about whether 3I Atlas is simply a comet, or something else entirely. On that day, the comet will pass within of Jupiter, less than 54 million kilometers. To put that in perspective, that's closer than Earth is to the Sun by a factor of 4. For Jupiter, a planet so massive its gravity can redirect asteroids and comets with ease, this encounter is a celestial crossroads. And waiting there, already orbiting the giant, is JUICE, ESA's flagship spacecraft. JUICE, the Jupiter Icy Moons Explorer, was never built to chase interstellar visitors. Its mission is to study Ganymede, Europa, and Callisto, hunting for signs of subsurface oceans and possible habitability. But fate has given JUICE a unique opportunity to point its cameras and sensors at 3I Atlas as it sweeps past. This is more than an opportunity. It's a test. The spacecraft carries high-resolution imaging systems, spectrometers capable of identifying molecular species, and particle detectors that can analyze gas and dust directly. If JUICE turns its instruments toward Atlas, the data could settle long-standing mysteries. The mass, the composition, the jets, the shape of the nucleus, all could be revealed with clarity we've never had before. But here's the fear: what if silence follows again? What if JUICE records stunning, impossible anomalies, only for ESA to lock them behind classified walls? The Mars blackouts set a precedent. If agencies refuse to release the closest ever images from MRO and TGO, why would they behave differently with JUICE? Skeptics whisper that any confirmation of artificial structure, any hint of deliberate design, would be too destabilizing for public release. Still, scientists are preparing scenarios. If Atlas is natural, what might JUICE find? Perhaps a large, rugged nucleus, 5 to 10 kilometers across, covered in layers of porous dust and frozen CO2. Perhaps jets bursting symmetrically across its surface, balanced by sheer coincidence. Perhaps nickel-bearing organics that mimic the behavior of manufactured compounds. This would be the cosmic coincidence explanation. Atlas is strange, yes, but still within nature's playbook. If Atlas is not natural, JUICE might reveal something entirely different. Imagine the shock if high-resolution images showed smooth planes, angles, or cylindrical geometry under the dust. Imagine if the spectrometers found ratios of metals not explainable by cosmic chemistry, patterns closer to alloys than minerals. Imagine if the jets themselves were not random sublimation, but controlled vents, aligned to maintain trajectory. And then there is the possibility of magnetic anomalies. Nickel-rich structures can interact with magnetic fields. If JUICE's magnetometers detect unexpected signatures as the comet passes, that could hint at internal organization. If it measures heat sources inconsistent with sunlight, it could imply engines or reactors hidden beneath. Of course, these are speculations. Mainstream astronomers caution against jumping to conclusions. But even they admit, JUICE has the tools to decide. And with Atlas leaving the solar system forever, this is our last chance. The flyby could also reveal how Jupiter's gravity interacts with such a massive interstellar body. At 33 billion tons, Atlas is heavy enough to feel Jupiter's pull without changing much in return. Still, gravitational slingshots are delicate dances. If the comet's trajectory shifts in measurable ways, we may be able to refine its mass estimate even further. Confirmation of the 33 billion ton figure would be one of the most astonishing measurements in astronomy. A planetesimal from another star, heavier than Mount Everest, drifting through our system. But let's not ignore the darker thought. If Atlas is truly artificial, then perhaps this trajectory near Jupiter is no accident. A flyby of the largest planet in the solar system could be deliberate, an opportunity to map the gravitational field, calibrate instruments, or even harvest data about moons like Europa, suspected of harboring life. In that case, Atlas isn't just passing through. It's observing, watching. Here, the Trojan horse analogy returns with chilling clarity. To Loeb and others, the idea is simple. What better disguise for an interstellar probe than a comet? Harmless, familiar, easily ignored. Yet inside, it could carry instruments, archives, or mechanisms beyond our understanding. By aligning its path with the ecliptic, it ensures flybys of planets and spacecraft. By cloaking itself in dust, it hides whatever lies beneath. And if JUICE sees something it shouldn't, will we ever know? ESA prides itself on openness, but history has taught us that governments are not always transparent when data brushes against the extraordinary. Already, some theorists predict that JUICE's data could vanish into a long review process, emerging only in fragments years later. Enough to satisfy curiosity, not enough to reveal the truth. Meanwhile, the comet marches on. After the Jupiter flyby, it will continue outward, climbing out of the solar system. By 2027, it will be gone, forever untouchable, carrying its secrets back into the void. That is why March 2026 is not just a milestone, it is the last window. Humanity will never again get this close to Atlas. This moment sharpens the divide between the two narratives. In one, Atlas is a natural giant, a statistical outlier, but still born of cosmic dust and gas. In the other, it is the first undeniable artifact of another intelligence, wandering the galaxy until, by chance or intent, it crossed paths with us. The Mars blackout taught us one lesson: silence is as telling as speech. If JUICE records anomalies and ESA remains quiet, suspicion will harden into conviction. If they release the data freely, and it shows only dust, ice, and jets, perhaps the mystery will soften. But if they release data that confirms the anomalies, nickel, mass, trajectory, then the debate will ignite like never before. And through it all, one truth remains. 3I Atlas is not just a comet. It is a mirror. A mirror reflecting our fears, our hopes, our hunger for answers. Whether natural or artificial, it forces us to confront the unknown. Whether agencies speak or stay silent, it forces us to question who decides what truths humanity can handle. The countdown to March 2026 has begun. The comet moves closer to Jupiter every day. Zeus waits. And the world, still reeling from silence, holds its breath. There are two stories being told about 3i Atlas. Both are extraordinary. Both change the way we see the universe. But they cannot both be true. The first story is the natural one. In this version, Atlas is a giant planetesimal, a piece of raw planetary material that formed around another star. Billions of years ago, it may have orbited a young sun-like star, mixing with other fragments in a crowded protoplanetary disk. Through gravitational interactions, perhaps a close encounter with a gas giant, it was ejected, cast adrift into interstellar space. For millions of years, maybe billions, it wandered the void, bombarded by cosmic rays, its chemistry altered, its water depleted. Eventually, by chance, its path intersected ours. This story explains the mass. Atlas is simply a big survivor, dense and rocky, not fragile like most comets. It explains the nickel. Organometallic chemistry is rare but possible, and interstellar environments could create compounds Earth has never seen. It explains the trajectory. Alignments happen, even improbable ones, and the ecliptic plane is wide enough to catch the occasional visitor. It explains the silence. Space agencies are overwhelmed, cautious, and sometimes slow to release data. If this story is true, the lesson is humbling but naturalistic. The galaxy is full of such fragments. For every Atlas, there may be countless more, wandering in darkness. Interstellar objects are more diverse than we imagined. Some are fragile slivers like Oumuamua, others are icy bodies like Borisov, and some are mountains of rock and ice like Atlas. They are messengers, fossils from alien star systems, carrying the chemical fingerprints of other worlds. Studying them can tell us how planets form, how disks evolve, how life's ingredients spread through the cosmos. But then there is the second story, the artificial one. In this version, Atlas is not a random fragment, but an engineered object. Its mass is deliberate, its symmetry intentional, its composition purposeful. The excess nickel, the strange dust, the perfect trajectory, all of it is by design. A disguise. A machine cloaked in ice and dust, made to look like a comet but built for another purpose. Perhaps observation. Perhaps exploration. Perhaps something else entirely. If this story is true, the implications are staggering. Humanity has not just discovered a comet, it has discovered evidence of intelligence beyond Earth. Not a signal, not a radio burst, but a physical artifact drifting through our system. A Trojan horse, as Avi Loeb put it, something that looks ordinary until you realize it is not. Imagine what this means. Civilizations beyond Earth exist, or existed. They build, they explore, they send emissaries into the stars. Atlas could be millions of years old, its creators long gone, its mission forgotten. Or it could still be active, recording, transmitting, watching us now. It could be a relic, or it could be a probe. Either way, it proves we are not alone. And with that realization comes unease. If Atlas is artificial, then who built it? Are they friendly? Curious? Indifferent? Or are they extinct, their probe a ghost drifting endlessly? The galaxy is vast, and civilizations may rise and fall across eons. Atlas could be a messenger from a long-dead world, its creators gone before humanity even walked the earth. Or it could be something newer, a scout from neighbors we have not yet met. Between these two stories lies the silence. The agencies that hold the best data refuse to speak. They know what the Mars orbiters saw. They know what Zeus will see. But they have not told us. And in that vacuum, suspicion grows. If the natural story is true, why not release the data? Why the blackout? Why the hesitation? If Atlas is just a comet, the public would celebrate the science. We would marvel at its size, its chemistry, its beauty. The secrecy seems unnecessary, unless the second story holds some truth. And if the artificial story is true, then silence makes sense. The revelation that we are not alone could shake governments, religions, economies. It could trigger fear, panic, or wonder. Officials might choose to control the message to protect the public or to protect themselves. Yet history shows that truth leaks. Oumuamua strange acceleration sparked debate. Borisov's pristine chemistry shocked researchers. Atlas is far more dramatic. Already, ground-based telescopes, amateur astronomers, and independent scientists are gathering evidence. NASA and ESA may control the highest resolution data, but they cannot control the skies. The truth will out, sooner or later. For now, the world balances between the two narratives. Some cling to the natural explanation, comforted by the idea that nature, though strange, is still nature. Others lean toward the artificial, convinced that Atlas is the first undeniable artifact of another intelligence. Both sides wait for the same thing: data. March 2026 will bring answers, one way or another. If JUICE captures images of a rugged nucleus, chemistry consistent with organics and ices, then perhaps the natural story wins. If JUICE finds symmetry, alloys, or geometry, the artificial story explodes into reality. And if silence follows again, suspicion will turn into certainty for many. The stakes could not be higher. Because whichever story proves true, the universe is not the place we thought it was. If Atlas is natural, then interstellar planetesimals are bigger, stranger, and more diverse than our models predict. Planet formation across the galaxy must produce giants, ejecting them like seeds into the void. Our solar system is not unique. Our cosmic neighborhood is littered with wanderers. If Atlas is artificial, then we are not the first. Civilization is not a local accident. Intelligence has blossomed elsewhere, and its relics now drift among the stars. Humanity's questions, are we alone? Are we first? Would be answered with a resounding no. And the very silence of Atlas, its refusal to signal or announce itself, would raise an even deeper mystery. Why? Both stories are astonishing. Both demand we listen, we look, we search. And as Atlas sails toward Jupiter, the clock ticks down. The truth is coming. Silence cannot hold forever. When an object like 3I Atlas drifts into our system, the data may be astronomical, but the consequences are human. We do not look at it only as a comet. We see it as a mirror, a question about who we are and where we stand in the universe. And depending on which narrative proves true, the implications ripple across every domain of human thought. Let us begin with a natural explanation. Imagine the press conference. NASA, ESA, and other observatories finally confirm that Atlas is indeed natural, a massive interstellar planetesimal. The data from JUICE, from Hubble, from JWST, all point to dust, ice, and organometallic chemistry. The nickel anomaly is explained by fragile complexes. The polarization curves are strange but natural, shaped by highly porous dust. The trajectory thug. The immediate reaction would be wonder, not fear. Humanity would celebrate the discovery of the largest interstellar visitor ever recorded. Headlines would proclaim, "Alien fossil from another star system passes through the solar system." Scientists would rush to publish, to debate, to update their models of planet formation. Textbooks would change. Students would learn that interstellar space is seeded with massive chunks of alien worlds. The philosophical impact would be profound. If Atlas is natural, then every star system may eject such objects. Every planet that forms may send fragments into the void. Our solar system is not unique, not privileged. We live in a galaxy of constant exchange, where dust and rock and ice cross the interstellar gulf. It suggests that the building blocks of planets, and perhaps life, are not confined. Panspermia, the idea that life spreads across the stars through comets and fragments, would gain new weight. If planetesimals wander everywhere, then so might the chemistry of life. Geopolitically, The natural explanation is the safe one. Governments would highlight scientific cooperation, international telescopes, global data sharing, the triumph of human knowledge. Funding for astronomy might increase, new missions proposed to intercept interstellar visitors. The discovery would inspire without destabilizing. Humanity would feel small, but connected, one species among many under a vast, natural sky. But then imagine the artificial scenario. Imagine if Zeus or Mars orbiters had captured images not of rugged ice, but of geometry. If spectrometers had measured alloys rather than minerals. If the trajectory proved not just aligned, but engineered. The announcement, if it ever came, would not be just science. It would be history. The first revelation, we are not alone. This single truth would overturn centuries of philosophy. Religions would confront it in different ways. Some would embrace it, proof that creation extends beyond Earth, that intelligence flourishes across the cosmos. Others would resist, interpreting alien artifacts as threats to dogma. Theologians would debate, are we still special? Do aliens fit within divine creation or challenge it? Entire traditions could fracture or evolve under the weight of contact without communication. For science, the implications would be a revolution. Astronomy would no longer be just observation of stars and galaxies. It would become archaeology of alien technology. The artificial scenario means intelligence has already left its fingerprints in space. Researchers would scramble to model not only planetary systems but civilizations. New fields would explode: astroarchaeology, xenotechnology, galactic anthropology. Every telescope would be redirected not only to stars, but to the relics drifting between them. For geopolitics, the artificial story is dangerous. Nations would demand access to the data. Rival powers would accuse each other of hiding or monopolizing it. If Atlas is an alien probe, who controls it? Who has the right to study it? Could it contain information, technology, or even threats? Secrecy would breed mistrust. Alliances might fracture. Militaries would want answers, fearing strategic implications. The world would suddenly confront a question it has never faced, not, what if aliens arrive? But, what if they already passed by, disguised as a comet? In culture, the artificial story would ignite imagination like no event in history. Movies, books, art, and music would explode with alien themes. Some would celebrate, others would fear. Conspiracy theorists would claim vindication. Utopians would dream of contact. Doomsayers would warn of hidden dangers. The narrative of humanity as the sole intelligent species would die overnight. We would have to rewrite our identity in the cosmos. And then comes the personal level. If Atlas is artificial, ordinary people would ask, what does this mean for me? Is Earth being watched? Are we in danger? Or are we irrelevant, just another life form passing under the gaze of an ancient probe? For many, it would be humbling. For some, terrifying. For others, exhilarating. The realization that intelligence is not unique to Earth would shatter the walls of isolation around our species. The silence of NASA and ESA becomes even more critical in this context. If the comet is natural, the blackout looks like bureaucracy, delay, or incompetence. If the comet is artificial, the blackout looks like control. It becomes evidence of a truth too large for agencies to reveal. And in an age of instant communication, such secrecy cannot last forever. Leaks would spread. Amateur astronomers would demand answers. The truth would fight its way into the open, whether through official channels or not. Either way, 3i Atlas has already changed the conversation. Even without confirmation, the anomalies have cracked open a door. People are asking questions they never would have asked before. Could comets hide technology? Could probes drift disguised for millions of years? Could civilizations leave relics instead of signals? These are not questions of science fiction anymore, they are questions of science. And this, perhaps, is the greatest implication of all. Natural or artificial, Atlas forces humanity to expand its imagination, to accept that the universe is stranger than we believed, to admit that we do not yet understand the diversity of worlds, or the possibilities of intelligence. Whether Atlas is fossil or artifact, it is a messenger. And its message is simple: we are not at the center. We are not in control. We are not alone. By late 2025, the story of 3I Atlas had escaped the laboratories and observatories. It was no longer confined to the quiet language of research papers. It had erupted into the bloodstream of global culture. The moment the silence from NASA and ESA stretched past 10 days, the internet filled the void. Reddit threads multiplied hourly. Hashtags like #WhereIsTheData and #CometGate trended worldwide. TikTok videos dramatized the blackout with eerie music and captions like, "NASA knows something." YouTube flooded with analysis, animations, and speculation. Could a 33 billion-ton interstellar object really be natural? Why did the agencies go dark? And why were independent observatories reporting faint geometric structures in the coma, while official images remained unreleased? Mainstream media tried to keep up. CNN aired cautious headlines. NASA delays release of Mars flyby data on interstellar visitor. The BBC called the silence perplexing but procedural. Meanwhile, fringe outlets declared apocalypse. Some claimed the Mars Reconnaissance Orbiter had photographed a metallic cylinder kilometers long. Others posted pixelated leaks from supposed ESA insiders, showing nothing more than noise and dust but described as alien architecture. Governments reacted unevenly. In Washington, NASA's Public Affairs Office issued a brief statement. Data from the Mars 2025 observation campaign are undergoing calibration. No unusual findings have been reported. The blandness of the wording only fueled suspicion. In Europe, ESA's Director of Science insisted that all data will be made public after peer review, a phrase many interpreted as indefinite delay. In China, the reaction was different. The Chinese National Space Administration hinted that its own ground telescopes were observing Atlas and promised transparent sharing. Whether this was genuine openness or geopolitical positioning, it worked. The world began looking east for answers. Russia's Roscosmos, typically silent on Western discoveries, released a cryptic comment on state television. Perhaps the Americans discovered more than a comet. Within days, the story had split the world into factions. The naturalists, who believed Atlas was simply a giant comet, argued that bureaucracy and caution explained the silence. The constructivists, convinced it was artificial, saw the blackout as a cover-up. Between them stood a third group, the agnostics, who didn't claim certainty but distrusted authority enough to suspect suppression. The naturalists filled forums with technical explanations, outgassing symmetry, statistical flukes, organic nickel chemistry. They shared graphs, simulations, and academic preprints. But few outside scientific circles read them. The constructivists, meanwhile, made documentaries, podcasts, and emotional appeals. They didn't need equations, they had intrigue. Their videos reached millions. Every news snippet of information, every radar echo, every blurry image, was dissected, enhanced, misinterpreted. When an amateur astronomer in Chile posted a faint linear streak near Atlas's nucleus, it was hailed by tabloids as proof of artificial structure. A week later, professionals confirmed it was a processing artifact. By then, the claim had been viewed 50 million times. Governments struggled to control the narrative. Intelligence agencies quietly began monitoring online communities that treated Atlas as evidence of extraterrestrial presence. Social media companies debated whether to label posts as misinformation. But the boundaries between fact and theory had blurred too far. In the absence of certainty, belief became identity. Some treated Atlas as prophecy, the fulfillment of ancient texts about messengers from the heavens. Churches and temples reported spikes in attendance. New spiritual movements emerged overnight, groups calling themselves the Watchers, or the Children of Atlas, preaching that the comet was a divine instrument, an eye of creation returning to observe its offspring. Others saw danger. Conspiracy theorists claimed governments were preparing for contact or invasion. Viral posts alleged secret military meetings, encrypted signals from the comet, energy spikes detected by deep space antennas. None of it held up under scrutiny, but in the public imagination, Atlas had already transformed from scientific object to mythic presence. By November 2025, even world leaders began to comment. The US president gave a cautious speech. "We encourage patience as our scientists analyze the data. The universe is full of wonders. Discovery takes time." In contrast, a European Parliament member demanded open disclosure. "Taxpayers funded these missions. We have a right to know what the Mars orbiters saw." Then came the leaks. An anonymous post on an encrypted forum claimed to include excerpts from internal NASA emails discussing reflectivity anomalies and non-ballistic movement of Atlas. The files turned out to be forged, but before verification, they spread like wildfire. Another leak, a short video allegedly from ESA servers, showed a pixelated object rotating slowly against the star field. Experts confirmed it was a simulation clip from a graduate student's project. The damage, however, was done. Each false leak only deepened distrust. If the fakes look this real, what must the real data show? By December 2025, Atlas had become more than a scientific mystery. It was a cultural phenomenon. Fashion brands released Atlas 33 billion tons designs. Pop musicians wrote songs about the silent comet. A Hollywood studio rushed a thriller into production titled The Fifth Anomaly. Behind the spectacle, scientists tried to hold ground. Peer-reviewed papers trickled out, technical, cautious, slow. They detailed polarization curves, CO2 ratios, and the comet's minimal acceleration. But even academic tone carried a hint of awe. One paper ended with an unprecedented sentence for a scientific journal. "The anomalies of 3I Atlas remind us that the cosmos may yet hold surprises that transcend our expectations." The information war intensified as the comet approached visibility again in early December. Amateur telescopes caught glimpses. Live streams on YouTube showed the faint smudge moving among the stars. Chat windows overflowed with speculation. Every flare of brightness became a signal, every pause in transmission proof of censorship. Then, abruptly, a new development. A small private observatory in South Africa released high-resolution polarization maps showing an oddly symmetric dust jet pattern. The image was real, verified by multiple astronomers. The symmetry wasn't perfect, but striking. To scientists, it was coincidence. To believers, it was confirmation. Governments doubled down on calm messaging. "Coincidences are not conspiracies," NASA tweeted. The reply section filled instantly with accusations of deceit. "Coincidences," one user wrote. "Don't weigh 33 billion tons." By the end of 2025, Atlas had become the world's most discussed object, more famous than any spacecraft, more mysterious than any UFO claim. It united and divided humanity at once, skeptics, believers, scientists, mystics. The comet had become an idea, a symbol of everything people hoped or feared about the universe. And above it all, the real 3I Atlas drifted onward, indifferent to our noise. Silent, immense, and glowing faintly blue in the darkness, it crossed the orbit of Mars and moved toward Jupiter. While humans argued, it simply moved. While billions speculated, it kept its secrets. The information war was only the beginning. The real confrontation, the moment of truth, was still months away, waiting in Jupiter's shadow. March 2026. the month humanity had circled on its calendars. For nearly half a year, speculation about 3I Atlas had dominated the news cycle, spurred by silence, fueled by leaks, and fed by the comet's own paradoxes. Now, at last, the object was about to pass within of Jupiter. And waiting there, in orbit around the giant planet, was JUICE, the European Space Agency's newest explorer. It was billed as a historic alignment of chance and technology. JUICE had not been designed to chase interstellar objects. Its mission was the icy moons of Jupiter, Ganymede, Europa, Callisto. But its cameras, spectrometers, and particle detectors were perfect for capturing data from Atlas as it swept past. Scientists described it as a bonus mission written by the universe. The build-up was electric. News outlets ran countdowns. YouTube streams scheduled, watch parties, even though no live images were expected. Avi Loeb gave interview after interview, warning that the comet might prove to be the most consequential object in history. Politicians demanded transparency. ESA tried to temper expectations. JUICE will observe 3I Atlas as conditions allow. Data will be processed and released following standard protocols. To the public, it sounded like another blackout warning. On March 12, 4 days before closest approach, amateur telescopes detected Atlas brightening unexpectedly. Some interpreted it as a normal flare of activity as jets intensified near Jupiter's reflected light. Others claimed it was a maneuver, as if the object were adjusting itself. Social media erupted with the hashtag #AtlasMoves. Astronomers countered with calm explanations, outgassing variability, viewing geometry. But believers weren't convinced. March 16th arrived. At 6 o'clock Universal Time Coordinated, Atlas passed through its closest approach, drifting 54 million kilometers from Jupiter's cloud tops. JUICE turned its instruments toward the faint blue traveler. And then, nothing. ESA released no live stream, no images, no commentary. Hours passed. The silence echoed like thunder. On forums and streams, anger boiled. Not again. They're hiding it. At ESA headquarters, the press office repeated a line. The data is being transmitted and will undergo calibration. But rumors began leaking almost immediately. An anonymous Twitter account, claiming ties to ESA contractors, posted, "JUICE saw geometric shadows. It's real." Within minutes, the tweet had 1 million views. Other anonymous posts followed, each contradicting the last. One said JUICE detected unusual magnetic fields. Another claimed a smooth cylindrical nucleus. Another insisted the comet fragmented in front of Jupiter. None were confirmed, but the speculation took fire. By March 17th, #AtlasProbe trended worldwide. Talk shows debated openly whether ESA was sitting on alien evidence. Religious leaders called for calm. Financial markets fluttered as investors panicked over disclosure risk. Governments issued vague statements. "We are closely monitoring ESA's analysis." Finally, on March 18th, ESA held a press briefing. The auditorium was packed, every seat filled with journalists. Millions watched online. The director of science stepped to the podium. His words were measured, his tone cautious. JUICE has successfully observed 3I Atlas during its closest approach to Jupiter. Preliminary analysis indicates that the object remains active, with jets producing significant outgassing. Its nucleus size is estimated at several kilometers, though precise measurements are ongoing. Spectroscopic data confirm carbon dioxide as a dominant component. Nickel signatures are also present. Further analysis is required before conclusions can be drawn. That was it. No images. No detailed numbers. Just confirmation of the same anomalies already known: CO2 dominance, nickel signatures, large mass. The press erupted with questions. Where are the images? When will they be released? Did JUICE detect magnetic anomalies? Why repeat what we already knew? The director's answer. The images and full data set will be made available after peer review. It was the same line as after the Mars flyby. To the public, it was not reassurance. It was betrayal. Protests broke out in front of ASA offices in Paris, demanding truth about Atlas. Hackers claimed to have breached internal servers. Within 24 hours, blurry photos began to circulate online, allegedly from JUICE. Some showed irregular comet shapes, others hinted at straight edges. None were authenticated. But the damage was done. The narrative split again. In one camp, the naturalists said ESA's briefing proved the object was a comet, jets, CO2, nickel, all explainable. The delay in image release was bureaucracy, nothing more. In the other camp, the constructivists insisted the blackout was proof of cover-up. If it was just a comet, they'd show us. They're hiding geometry. Avi Loeb added fuel to the fire. In an op-ed he wrote, "We are at the crossroads of history. Either 3I Atlas is the largest natural object of its kind, or it is an artifact. The silence from agencies only deepens suspicion. Transparency is the only path forward." Meanwhile, whispers grew louder. A European tabloid published a sensational claim that Jews had captured high-resolution images of a nucleus shaped not like a lump of rock, but like a smooth spindle. The article cited anonymous ESA scientists. ESA denied the story, but public trust was gone. Across the world, people watched the comet drift past Jupiter. It was invisible to the naked eye, but visible in imagination. To billions, Atlas was no longer just a comet, it was a question hanging in the sky. Was it a fossil, or a machine? A natural wonder, or a Trojan horse? The days after the flyby saw chaos. Markets dipped, conspiracies surged, churches filled, and memes flooded every platform. Some mocked ESA's silence with jokes. The comet ate the data. Others whispered apocalypse. But beneath the noise, one truth persisted. The comet still moved outward, carrying its secrets. By 2027, it would vanish forever into interstellar space. The Jupiter flyby was humanity's last, best chance. And ESA's silence ensured that, even in the final moments, certainty remained out of reach. Atlas had given us anomalies. It had given us debates. It had given us silence. Now it gave us a new legacy, division. Half the world believed in the natural story. Half the world believed in the artificial. And both sides were convinced the other was blind. The comet had crossed Jupiter, but humanity had crossed something bigger, the threshold of imagination. We could no longer look at the sky the same way. Every faint object drifting through space would carry a new suspicion. Every silence from an agency would spark 1,000 theories. By the time 3I Atlas began to fade into the outer solar system in late 2026, the comet had already carved itself into human history. It did not need to reveal its full truth. The silence, the anomalies, the speculation, together they reshaped how we think of the cosmos. Even as the comet retreated into the black, its impact on us was only beginning. Let us pause and reflect. What was 3I Atlas? If the natural story is true, then we have witnessed the greatest fossil of our generation. A 33 billion-ton fragment from another star system, hurled across the galaxy and caught, briefly, in our solar system's light. Its chemistry was strange because its birthplace was alien. Its mass was immense because it survived what smaller fragments could not. Its trajectory aligned with ours not by intent, but by the relentless statistics of the cosmos. In this version, Atlas humbles us. Nature is more creative than we imagined, more diverse than our models dared predict. If the artificial story is true, then Atlas was never just a comet. It was a construct, a vessel, a machine cloaked in dust and gas. It was a Trojan horse slipping silently past our planets, recording, observing, maybe waiting. In this version, we were visited not just by matter but by mind. an artifact of intelligence not our own. Perhaps ancient. Perhaps recent. Perhaps still alive in its silent systems. If this is true, then humanity's place in the cosmos changed the moment we saw it. We became witnesses, not alone but observed. And yet, whether natural or artificial, the result is the same. We will never look at the night sky the same way again. The comet has become a symbol. It symbolizes the limits of authority. NASA and ESA's silence, whether born of bureaucracy or secrecy, showed the world that institutions are no longer trusted to hold truth alone. The public demanded answers and, when denied, made its own. The comet became not just a scientific object but a battleground of belief. It symbolizes the hunger for meaning. Billions of people who had never cared about comets suddenly cared about this one. They saw in Atlas a messenger. Some saw prophecy, others conspiracy, others hope. It didn't matter whether the science was conclusive, the story itself was enough to inspire. For the first time in decades, humanity turned its collective gaze outward, together, toward a single object in the sky. It symbolizes our fear. The thought that a 33 billion-ton object could move through our system, immune to thrust, massive beyond measure, is unsettling enough. To imagine it might not be random but deliberate is even more so. What if it is a probe? What if it is a scout? What if it is watching us now? These fears may never be confirmed, but they will never fully fade. And it symbolizes our possibility. Because whether natural or artificial, Atlas shows us that the universe is not empty. If natural, then every star throws its fragments into the dark, and the galaxy is filled with wandering messengers. If artificial, then intelligence blooms beyond Earth, and we are not unique. In either case, we are part of a larger story. As the comet drifted past Jupiter and into the void, one undeniable truth remained: humanity itself had changed. Scientists proposed new missions, interstellar interceptors designed to chase the next Atlas, to meet it not with delay and silence, but with answers. Politicians debated international cooperation, realizing that no single nation should control the truth of the cosmos. Citizens stared at the stars with new eyes, wondering which faint smudge might be another messenger. And in cultural memory, Atlas will never fade. It will be remembered as the comet of silence, the comet of anomalies, the comet that made humanity argue with itself. It will be remembered as the comet that whispered, "The universe is stranger than you think." Perhaps one day, centuries from now, another Atlas will come, and by then humanity will be ready. Perhaps we will have ships to meet it, to land, to peel back the layers and see whether it is stone or steel. Perhaps by then we will know if we are alone, or not. But until then, 3i Atlas remains both question and answer. A question, because we may never know its true nature. An answer, because it already proved one thing: the galaxy is alive with mysteries, and we have only just begun to look. And maybe that is the final gift of Atlas. It arrived without invitation, slipped past Mars and Jupiter, and left us staring into the unknown. It forced us to confront our place in the cosmos, our distrust of authority, our hunger for wonder, and our fear of the other. Whether it was natural or artificial, comet or construct, it doesn't matter. It was enough. Enough to remind us that the sky is not silent. Enough to remind us that discovery is not safe. Enough to remind us that we are explorers, whether we like it or not. 3i Atlas is gone now, fading into the abyss. But it left behind a legacy written not in dust or nickel, but in us. Humanity is different now. We are watchers of the sky, dreamers of the void, children of a universe that still holds secrets beyond imagination. Before 3i Atlas, the world already had two brushes with interstellar mystery. The first came in October 2017, when a faint object passed silently through our solar system. It was named Oumuamua, Hawaiian for a messenger from afar arriving first. And true to its name, it changed everything. At first, astronomers thought it was a comet, then an asteroid. But the more they looked, the stranger it became. Oumuamua was tiny, perhaps only a few hundred meters long, but its shape was bizarre. Observations suggested it was elongated, maybe a cigar or a pancake, tumbling end over end as it moved. Its brightness shifted dramatically, as though sunlight glinted off flat surfaces. And then came the greatest anomaly. It accelerated slightly as it left the solar system, as though pushed by an invisible hand. Comets accelerate when outgassing jets fire off their surfaces. But Oumuamua showed no visible tail, no coma, no jets. To this day, no one has explained its acceleration in a way that satisfies every question. Some suggest hydrogen ice sublimation, others exotic ices, others thin flakes of material like cosmic sails. Avi Loeb, famously, suggested it might be an artificial light sail, a probe drifting on sunlight. The debate still rages. 2 years later, in 2019, came the second visitor, 2I Borisov. Unlike Oumuamua, Borisov looked familiar, a comet with a visible tail, outgassing dust. It was discovered by amateur astronomer Gennady Borisov and confirmed to be interstellar by its hyperbolic trajectory. But though it looked like a comet, it too carried secrets. Spectroscopy revealed its chemistry was pristine, untouched, unlike solar system comets that had been warmed and recycled by countless orbits. Borisov carried alien ices, frozen since birth in another star system. Where Oumuamua raised suspicion of artificiality, Borisov reassured. It was just a comet, but one from another sun. Together, they told humanity a new story: interstellar objects are not rare. They pass through our system, unseen until now, perhaps all the time. The universe is not closed, it is porous, exchanging fragments like seeds in the wind. And then came 3I Atlas. Compared to its predecessors, Atlas is a leviathan. Oumuamua weighed a few tens of thousands of tons. Borisov, though active, was small by comet standards. Atlas, by contrast, carries a minimum mass of 33 billion tons, 1,000 times heavier than Everest, 1,000,000 times greater than Oumuamua. It is not a messenger sliver, but a giant. Its anomalies, too, outshine its predecessors. Where Oumuamua had strange acceleration, Atlas has almost none, despite violent outgassing. Where Borisov showed exotic but natural chemistry, Atlas shows nickel without iron, and dust polarization curves unseen before. Where Oumuamua's trajectory baffled with acceleration, Atlas baffles with perfection, aligned to the ecliptic within 5 degrees, skimming planets like a surveyor. It is as if the universe is escalating. First, a small, ambiguous messenger. Then, a comet that confirmed the reality of interstellar wanderers. Now, a giant, heavy, anomalous traveler whose silence provokes both awe and suspicion. And what ties them together is what we did not know. Oumuamua left too quickly, before telescopes could study it. Borisov, though active, was faint and short-lived. Atlas is the first one we've watched in detail, with Hubble, JWST, VLT, and orbiters. And still, the silence remains. Some call it coincidence. 3 objects in less than a decade, after none were known for centuries. But others ask, why now? Has our detection ability improved that much? Or are we entering a region of the galaxy seeded with such messengers? If Oumuamua was a scout, Borisov a distraction, and Atlas a Trojan horse, what comes next? The ghosts of Oumuamua and Borisov haunt the story of Atlas. They whisper from the past, this is not the first time you've doubted, not the first time you've wondered if nature is enough to explain what you see. Atlas magnifies those doubts, makes them heavier, darker, impossible to ignore. One thing is certain. When future generations tell the story of humanity's first contact with interstellar visitors, they will not tell it as separate tales. Oumuamua, Borisov, Atlas, they will be chapters in one book. A trilogy of arrivals. The first strange, the second familiar, the third overwhelming. And if there is a fourth, what will it be? A comet, a shard, a probe, a ship? The ghosts do not answer. They only warn us, pay attention. The messengers are passing, one by one, and each carries a story larger than itself. The silent wars of agencies. When the orbiters at Mars turned their instruments toward 3I Atlas, the world expected a flood of images. Cameras like HiRISE on MRO could capture features sharper than anything ground telescopes could see. Spectrometers on TGO and Mars Express could analyze the gases venting from its surface. For the first time in history, humanity had spacecraft positioned perfectly to study an interstellar comet up close. And yet, after October 3, 2025, nothing came. Days turned into weeks, weeks into months. NASA and ESA spoke only in cautious phrases. Data under calibration. Peer review required. Release pending. No images. No raw spectra. Just silence. To the public, it looked like a cover-up. To insiders, it looked like a war. Space agencies are not just scientific institutions. They are political entities, woven into the priorities of governments, alliances, and budgets. Their missions are paid for by taxpayers, overseen by politicians, and entangled with national security. And interstellar objects like Atlas are not just curiosities, they are potential game changers. Imagine what would happen if the Mars orbiters revealed geometry. A cylinder. A spindle. Angles too straight for nature. If such images were released unfiltered, the shockwaves would be immediate. Stock markets could tumble, religious institutions would scramble, governments would panic over who controls access. The first question asked in every parliament would not be what is it, but who owns it. For NASA, the silence may be protective. Officials might fear panic, fear ridicule, or fear geopolitical fallout. If Atlas turned out to be a probe, the United States would want to control the narrative, not share it. Information would be classified, handled like a military intelligence asset. In Washington, extraterrestrial technology would not be science, it would be security. For ESA, the motives may be different. Europe prides itself on openness, but it also relies heavily on international cooperation. If Jews detected anomalies, ESA might hesitate, waiting for consensus with NASA before risking a unilateral disclosure. Silence becomes diplomacy. Better to delay than to ignite controversy. Then there is China. While NASA and ESA kept quiet, the Chinese National Space Administration dropped hints that its own observatories were tracking Atlas. Whether these hints were genuine transparency or political theater, they worked. Global eyes shifted. If the West stayed silent, China could seize the narrative, presenting itself as the voice of cosmic truth. For Beijing, Atlas was not just a comet, it was soft power, leverage in the new space race. And Russia? Roscosmos, weakened by years of underfunding, still understood the stakes. Russian state media suggested darkly that perhaps the Americans discovered more than a comet. A veiled accusation, designed not to reveal truth but to erode trust in NASA. In geopolitics, silence can be weaponized. Behind the scenes, intelligence agencies likely weighed in. Anomalous data from Atlas could blur the line between astronomy and defense. If an interstellar object could maneuver, or worse, if it contained unknown materials, it would be treated as a potential threat. Agencies like the CIA or the European Defense Agency might demand classification. Scientists might have data on their computers but be forbidden to publish. Silence then becomes enforcement. The blackout after Mars was not the first time. History shows a pattern. Governments controlled the release of extraordinary space data. The Pentagon sat for years on Navy UFO videos before acknowledging them. Soviet missions in the Cold War kept silent about anomalies detected on Venus. Even the famous "Wow" Signal of 1977 was quietly buried in academic journal. But silence has a cost. The longer agencies wait, the more the public fills the void with rumor. The absence of data becomes its own anomaly, fueling belief that something is hidden. The more NASA says, peer review, the more people hear, cover up. The more ESA promises, eventual release, the more the world suspects manipulation. Trust erodes. And then there is money. Scientific missions run on budgets, and budgets run on perception. To admit that Atlas is artificial, or even plausibly artificial, would ignite both opportunity and fear. Funding would skyrocket for interception missions, deep space observatories, defense systems. But at the same time, backlash could follow, citizens demanding to know why they weren't told sooner, or accusing agencies of hiding alien technology. Silence may be a way to buy time, to prepare the political ground before the truth lands. Some insiders whisper that the blackout was not total. That scientists at NASA and ESA were given quiet, gag orders, until data could be reviewed by committees including military liaisons. That the Mars images were stored in restricted servers. That even JUICE's raw frames were encrypted during transmission to Earth. If true, then the silent wars are not just between nations, they are within them. Scientists fighting for openness. Governments demanding control. In the end, the silence surrounding Atlas may tell us as much as the comet itself. Nature does not withhold. Nature does not redact. Humans do. Whether the comet is a natural wonder or an artificial artifact, the way we handle its data is a reflection of us, not it. Atlas has exposed the cracks in our institutions. The gap between science and politics. The mistrust between governments and citizens. The fear that truth is too powerful to release unfiltered. These are not anomalies of the comet. They are anomalies of our civilization. And so the silent wars continue. NASA waits. ESA waits. China teases. Russia provokes. The public speculates. Meanwhile, 3i Atlas moves on, indifferent to our secrecy. It doesn't care who wins the war of narratives. It doesn't care about cover-ups or leaks. It is what it is, comet or construct.